So if we look at a worked example of that, and it also gives us a kind of common context to that as well. And that is looking at what are called cathode ray tubes. Now these are the old style televisions as well, but they're also used in physics labs to demonstrate these sorts of ideas. Basically, when these were first made, we didn't actually know what these particles were that are coming out from the cathode, so they were known as cathode rays. And basically what we now know is that they're electrons, and if we create a voltage between the negative cathode and the positive anode, then that will accelerate the electrons across us. Because that's a cylinder, any electrons which aren't along that central line will be deflected, attracted out the way. And what that leaves is a nice well-defined beam to travel to the screen. So what sort of questions might you be asked? So if you're told the potential difference between the anode and the cathode, okay, and then we can work out the horizontal speed of the electron. And then we'll discuss how that changes. So using the idea that change in kinetic energy of the electron is the work done, the electrical work done, so the energy provided by the 150 volts. So given the electron started from rest, so the change in kinetic energy is the final kinetic energy, half mv squared minus 0, and that must be equal to QV. Plugging in once again our standard values for the charge of the electron and the mass of the electron, then we can solve this to find the speed of the electron as it reaches the anode. And once it's left the anode, then there's no electric fields on here, so nothing to change the speed beyond that point. So basically it should hit the screen at the same speed. And it's also assumed there's no collisions, which is why these are done within a vacuum.